Science and Mathematics, Bridging Theory with Real-World Innovation, Rethinking School Curriculum. I would suggest that we stop treating math and science as purely academic subjects and start recognizing them as living, evolving disciplines that shape the world around us. If you think about it, students often struggle with these subjects not because they lack ability, but because they fail to see the relevance in their daily lives. Do you honestly believe that memorizing formulas and equations without real-world application fosters genuine understanding and innovation? For instance, NLP, Neuro-Linguistic Programming, tells us that different students engage with learning in different ways. A kinesthetic learner will only truly understand Newton's laws of motion by building and testing a small car, experimenting with gravity, or constructing a catapult. Meanwhile, a visual learner will absorb complex mathematical concepts much more effectively through interactive simulations, dynamic graphs, and visual problem-solving models. An auditory learner may connect best through discussions, problem-solving debates, and real-world case studies explained through storytelling. Is it not desirable that we restructure math and science education in a way that adapts to these learning preferences, ensuring deeper comprehension and retention? Now, let's bring in MBTI, Myers-Briggs Type Indicator. An INTP, the logician thrives in abstract thinking, theoretical exploration, and independent discovery, making them well-suited for open-ended research projects, coding challenges, and mathematical theory discussions. Meanwhile, an ESTP, the entrepreneur, might connect better with practical applications, real-time problem-solving, and hands-on engineering projects. If we want to make math and science engaging for all, we need to create multiple entry points. Some students will be drawn to logic and analysis, while others will engage more deeply through experimentation and innovation. Looking at the Enneagram, a Type 5, the investigator, is naturally inclined towards scientific discovery, deep research, and technological advancement, while a Type 3, the achiever, might be motivated by math and science competitions, STEM entrepreneurship, and innovation-driven projects. A Type 1, the reformer, may gravitate toward precision-based disciplines such as engineering, architecture, or data science. A truly effective science and math curriculum should align with these motivations, ensuring that students engage based on what excites them most. If you think about it, science and math shouldn't just be about solving equations on paper. They should be about solving real-world problems and fueling curiosity. A dynamic, evolving curriculum should go beyond rote learning, ensuring that every concept is reinforced through hands-on, interactive experiments and simulations. Encourage curiosity-driven learning, allowing students to explore scientific questions, develop hypotheses, and test their ideas in real-world scenarios. Incorporate NLP principles, ensuring students grasp mathematical and scientific principles in ways that suit their learning styles, whether through visual models, interactive discussions, or hands-on experimentation. Leverage MBTI strengths, creating pathways for both theoretical thinkers and practical problem solvers. Use Enneagram insights to align learning experiences with intrinsic motivations, whether students are drawn to discovery, competition, precision, or real-world impact. Do you honestly believe that students will develop a passion for math and science if they don't see how these subjects shape the world around them? A truly impactful curriculum doesn't just teach theories. It immerses students in problem-solving, discovery, and innovation, ensuring they see math and science as powerful tools for shaping the future. The real question is, are we ready to transform science and math education into an exciting, hands-on journey of exploration and real-world application?